Hello everyone, I hope you are doing well. So in today's video, I'm actually going to go through the Northern Hemisphere of, for Maths Methods Exam 2 multiple choice section. Now, it just came out yesterday, so I'm going to go through my suggested solutions. I'm at uni right now, so I'm going to go quick with this. Yeah, let's go. Okay, the period of the function y equals 3 sine 2x blah blah blah. Okay, so the period is just 2 pi over 2, which is pi. So B is your answer for the first one. Next question. Question 2, blah, blah, blah. So this is your function. The instantaneous rate of change of f when t equals 1 is... Okay, I'm going to go on my calculator, and what I'm going to do is define f on t straight away. So define that. Okay, it is -1, okay, times t to the power of 3 over 3 plus 0.5 t squared plus 50t. And so we want to find the derivative of the respect of t for f on t, given that t is equal to 1. Okay, 50 is your answer. So C is your answer. Okay, question 3. The function this is strictly decreasing over the domain. Okay, so to find that, what we're going to do is we're going to find f dash of x, which is blah, blah, blah. And we want to solve when it's less than 0. So let's go on our calculator. And so, let's define f on x. Okay, nah. Let's just control N and make a new one. Okay, so what we want to do is define f of x equals the root of 3 minus 2x minus x squared. Now, what we want to do is we want to go algebra. Okay, first we want to solve where the derivative of f of x is less than 0, comma x. Okay, so it's from -1 to 1, non-inclusive. So B should be your answer. Okay, is that right? Looks like. Okay, question 4. Consider the polynomial with the equation, okay, this, where p is less than 0 and n is a positive whole number larger than 0. The highest value of n from the options below, for which the graph of y equals f of x has exactly one x-intercept. Okay, so what I'm going to do for this one is I'm going to control N and go on my CAS. And I'm going to go on graph, and I'm going to let first p, because p is less than 0, let me just say p is -1 for this. So x to the power of n, and p is -1, so we're going to say -x plus 1. Okay, and we can put a slider for n. So when n is equal to 1, it is a straight linear line, we can see. So there is actually no x-intercept for that one. So what about B when n is equal to 2? Question. So, all right, still no exactly one x-intercept. So what about 3? Aha, we get an x-intercept. So, but what about we have to do 5 because we want the highest value. So 5 we also get. And what about 7? Also. Okay, so your answer for this one is E, 7, because we want the highest value of n from the options below. Okay, question 5. The probability distribution for the discrete random variable is shown below is. So do we want the expected value? So I'm going to go on my calculator and say 0.4 times 2 times 0.3. I'm supposed to plus this accidentally times here. So okay, so this times plus this. Okay, 2 times 0.1. That gives you 6 over 5, which is... Okay, have I done anything wrong? Because it's not... So wait, let me double check. So 1 times 0.4, 2 times 0.3 times... Okay, here. Oh, I've accidentally put... It's supposed to be 3. Okay, 1.3. So B is your answer. So B. The range of the function this 10... Okay, we're given a domain, so... I'm just going to graph this quick. Go on graph, and I'm going to... So it's 2tan pi times x over 2, given that we're going from 0, x from half. Okay. And we get this. Okay, so the range is from 0 to 2. They are inclusive, by the way. So 0 to 2 inclusive. So E is your answer. Question 7. If this, so from -2, 5, f of x is 3, and 1 to 5 is this, and we want to find negative 2 to 1. Okay, so for this, I'm just going to go draw a quick graph. Okay, so we know that, let's say this is 1. Okay, sorry. This is 1, this is 5, and say this is negative 2. And we know that 1 to 5 is a negative number, so it must be probably like this. We say negative 2, so it's a negative integral. And we know that we want to find negative 2 to 1. But we also know that negative 2 to 5, so from negative 2 to 5, it's a positive value. So it means this value is supposed to be bigger than this value over here. So, and we don't know what value that is, so that's x, and that's what we're trying to find out from negative 2 to 1. And so we can say x minus 2 equals 3. So x is equal to 5. A should be your answer for this one. A, if I'm not mistaken. So 7, A. Okay. Okay, the weights of an apple that has been picked from an orchid are normally distributed with a mean of 182 grams, a standard deviation of 10 grams. 25% of the apples are not heavy enough to be sold at a supermarket. What is the minimum weight required for an apple to be sold at a supermarket rounded to the nearest integer? Okay, so I know for a fact that so this is your mean, which is 182, and we have some very low mass, and 25%, so we know that 25% of the apples are not heavy enough. So this mass is your minimum weight. So greater than that, they are able to be sold. The other one will be less if they are below, which is the 25%, they are not enough. So what I'm going to do is go on my calculator, and I'm just going to go to probability, distributions, and normal, inverse normal actually. So the area is 0.25. So 0.25, your mean value is 182, and your standard deviation is 10. That is 175. So 175 to the nearest integer, yeah, so 175. So your answer is A, question A. Next question, the area between the graph this and the lines this and this. Okay, what I'm going to do is, I have no idea what it looks like, so I'm going to go on here, and I'm going to, so x to the power 3 minus x squared. Okay, minus x squared minus 2x. Okay, and what I'm going to do is I'm going to go graph some relations, like, so y equals 0 is a relation. Also, we know that x is negative 1. We also know that x is equal to 2. So what we're trying to find is the area bounded by these, area between these graph and that. Okay, so I'm going to move this. So we want to find the area from this part of this area and also this area over here, which is, if I'm not mistaken, so which would be, okay, the first part from negative 1 to 0, we can say negative 1, 0 of the function f on 3. So f3, we put f3 on x, and this is a negative, this will be negative, so we must turn this to positive. So we're just going to put negative integral from 0 to 2 of f3 of x, comma x. The answer is 37/12. So C is your answer for this one. Question 10. A person rolls 5 fair 6-sided dice. The outcome for each of the dice rolls is independent of the outcome, blah, blah, blah. So it's independent, so we're using binomial for any other dice. What is the probability that the odd number? Okay. So we know that the probability of getting an odd number is half. And we want the x value to be 3. We want 3. And n is equal to 5 because he rolls them 5 times. And we want 3 times where they're odd. So we're going to go on go on calculator, go on probability, go on distributions, normal PDF, and we know our x value is 3. Your mean value is, oh, what? Wait, what am I doing? Oh, it's normal. Oh my god, what am I doing? Okay, it's probability, distributions, go to binomial PDF. So the number of trials is 5, probability of success is 0.5, and your x value is 3, which is 0.125, 0.3125. Which one's that? Looks like B is your answer for that one. Next question. Question 11. If u is this, v is this, where g is a differentiable function, then d dx. Okay, so the product rule. Okay, I know that the product rule is u dash. Okay, wait, so it's u v dash plus VU dash. So what's U? So it's G of X. What's V dash? Okay, the derivative of this is, it'll be 2 G dash 2X. Is that right? So if I bring the 2 in there, G dash 2 E G dash 2X. Okay, now I'm going to put this, so that's, okay, so it'll be 2 G dash 2X E G 2X plus, so V, which is E G 2X, multiplied by U dash, which is just D dash of X. What is a common factor? Okay, we have a common factor of G2X. So 2G GX G dash 2X plus, okay, plus G dash of X. So which one does it look like? E G2X 2GX G dash 2X plus GX. Looks like D is your answer. Is that right? So G dash of X, G dash of 2X plus G. Okay, looks right. D is your answer for that one. Next question. The graph of f of X is shown below, blah, blah, blah. Okay, for graph of f dash of X. Okay, so this is all positive. This has a positive gradient, and also this one has a positive gradient. So what I know, it's going to be, the graph is going to be all above the x-axis. So only C is your answer. The other ones go below. Okay, next question. Oops, what happened? Okay, wait, is it, okay, question 13. A tangent to the graph of y equals blah, blah, blah passes through the origin. The x-coordinate correct to decimal where the tangent line touches the graph. So a tangent line to the graph of this passes through the origin. The x-coordinate to decimal place where the tangent line touches. Okay, to do this, I'm just going to do it on calculator. So I'm going to go on my CAS. I'm going to control N. Okay, and I'm going to just first define the function. So define f of x as natural log. So I'm using natural log because it's quicker to write like ln than log e. So ln x minus 2. Okay, we got this. And what we want to do is, so let's try the x value x for first one. So negative 0.66. So I'm going to go on calculus, tangent line, f of x, comma x, comma, so negative 0.66. Okay, so domain error, so it doesn't even exist. So let's try the next one. Next one is 1.25. Also, this one doesn't exist. Try the next one. 2.91, which was 2.91. Okay, control enter. Okay, so we want where it passes through the origin. We know that the tangent line passes through the origin. So we want the C value to be close to 0. So this one, let's try the next one, which was 4.19. Okay, here we're getting so close. So this is actually 0. I want to check the last one. Maybe it's more. So 6.33. What have I done here? Oh, I'm supposed to bring this here, sorry. Okay, 6.33, so 6.33, which is 1.54. Okay, so your answer should be 4.1. So this one, because it's closer to 0, the origin. So we would say, question 13, D is your answer. If I'm going to say a tangent line to this passes through the origin, the x-coordinate correctly this one. Okay, makes sense. Okay, there are 2 boxes of sweets. Box 1 contains 5 strawberry flavored sweets and 7 lemon flavored sweets. Box 2 contains 6 strawberry flavored sweets and 12 lemons, blah, blah, blah. You choose a box randomly selects a single sweet. Given that you pick a strawberry, okay. Given that you pick the strawberry sweet, what's probably, okay. So we want to find the probability of where it came from box 2. So B2, given that you pick a strawberry flavor. So let's say strawberries S, which this is just probability of B2 intersection S over the probability of just S. So if I'm going to draw a tree diagram and say this is box B1, this is B2, we have strawberry lemon, and we know that these are both half. And so for the strawberry for box 1, we know that there is 5, but what's the total? So 7 plus 5, which is 12. So 12. This one should therefore be 7 on 12. And for the box 2, we know that there is 6 strawberries. And what's the total? So 6 over 18 and 12 over 18. And we want to find B2 over B2 intersection S, which is this one over here. So we're going to say half times 6 on 18 all over the probability of S, which is half times 5 over 12 plus half times 6 over 18. Okay, doing this by calculator. So going to my calculator and just putting this over here. So we're saying 0.5 times 6 over 8. So 6 over 18. And then here we will write 0.5 times 5 over 12. 5 over 12 plus 0.5 times 6 over 18. Okay, we get 4 over 9. So 4 over 9, do we have an answer? A looks like an answer for, okay. Question 15, for a continuous random variable x, blah, 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 we have this. Where a is a positive real constant, the variance of x would be what? So we know that the variance of x is from negative 2 to 6, so 2 to 6 of x minus your mean value squared f of x dx. But we don't know our mean value and we don't know the value of a. So to calculate the value of a, I'm going to go on my calculator. I'm going to control N this. Okay. To calculate the value of a, I know if we integrate from 2 to 6 for the function a times 6 minus x times x minus 2 times x plus 2. So we integrate this with the respect of x dx, and we know it should equal to 1 because it's probability and we're calculating the whole thing. And so a is 1 over 64. So, okay, just let me write solve, answer, comma, a. So we get a equals 164. Now we know a. To find the mean value, we know that it's from 2 to 6, x times this function over here, if I put it over here. And we know our a value is what? Now it's 1 over 64. And with the respect of x, that gives us 62 over 15. Now going back to find the variance, so variance is 2 to 6. It's x minus your mean value, and we want to square that, times f of x, which is this one over here. If I put that over here, comma x, we get this value, which is, if we simplify this, 0.782. 0.782. Okay, E is your answer. Is that right? 15. So question 15E, yep, looks right. Moving to the next question. All right, let f be this and g is this. The largest domain for which g of x is defined is. Okay, so we want the inner function, so which is 3x minus 1, to be pretty much between the values from root 3 to negative root 3, this domain over here, the outer function. So the largest domain would be, if we solve this, negative 3 plus 1, 3x root 3 plus 1. If we divide all by 3, so it'll be negative 3 plus 1 over 3. X will be root 3 plus 1 all over 3. Which would be 1 minus 2. Looks like B is your answer. Is that right? The largest domain for which g of x is defined. Okay, looks not... Okay. Looks right. Is that how... So this function, the inner function must be in the range of this. It must be in the domain of this. And yeah, looks right. The function this has more than one solution given. Okay, to do this, I'm just gonna... I know it's the... So what I'm going to do is using the discriminant. So I'm just going to say solve. Okay, so it's b squared, which is k squared in this value. So it'll be k squared minus 4. Our a value is 1, so and c is 2. We want it to be greater than 0 because we want more than one solution, comma, k. And we get k must be less than 2 in this. So it will be E. So K is negative, less than negative, not included, but looks right. 7.18. An investment firm models a particular financial investment using the equation this, where V is represents the value of investment after T years, and A and B are positive or constant. The investment from the investment firm deducts a fee from the initial investment amount before the interest is calculated. After 10 years, the value of the investment is this, and after 20 years, the value is this. The initial investment amount given to this was this, and approximate. Okay. So if I know that V on T, which is this value over here, which is B1 plus AT, so we know that the initial, so when V is 0, should equal to 10,000. So that will be, if I put 0, it'll just equal B is 10,000. So you are saying that B is your initial, but the problem is it's not 10,000 because they said that the investment deducts a fee from the initial investment beforehand. So B must be less than 10,000. So it's not these ones over here. Okay, to calculate this, I'm just gonna go. I know at least that V on 10 is equal to 12,000, and V on 20 is equal to 15,000. I'm gonna use my calculator to solve that. So Control N, I'm gonna actually define V on T. So define V on T is equal to B times 1 plus A to the power of T. Okay. So I know if I go to algebra, systems equation, and we want to solve for A and B, of this equation, we know that V of 10 is actually equal to 10,000, and we know that V of 20 is equal to 20,000. Is that right? 20, 15. Wait, what am I doing? Wait. 12,000 and the other one's 15,000. Is that right? Wait. So after 10 years, what am I doing? So after 10 years, the investment was 12,000 and 20 was 15,000. So we press enter, control. We get A is equal to -2 and B is this. Okay, so but we don't have any value of A like that. So let's go to the next one. A is 0.9. Okay, so do we have any that one looks like this? So 0.026. Okay, A looks right. A looks like 9,600, which is here, and 0.026. Looks right. Question 19. I'm not too sure, but yeah, it looks right. Question 19. The graph of y equals this. For k is an element or else has a tangent with a maximum horizontal x-intercept. Okay. So k is an element of all reals. So let's say that k right now is a positive value. So let's say k is 3. So if I'm going to sketch this, so it'll be the asymptote, which will be over here. So let's say this is your value of k, and the graph will look like this. If we're going to let x equal 1, the tangent at x equals 1, so let's say, okay, x equals 1 wouldn't even exist over here if we're saying k is equal to 3. So when k equals to, yep, because k is equal to 3. What about x is equal to k? Nope, wrong. It's because it's an asymptote. How the hell? There's no tangent to it. What about x equals e2? Still wrong, because it's still over here. What about x equals 1 plus k? So k plus 1, which is 4, which is over here. So the tangent will go like this. So, okay, we get this x value. Looks right. What about the next one? E plus k. So let's say that's like 2 point. So it's more than that. So it will be over here. So still, D has the maximum because it has the highest value of x. So I think D is right. D is right, man. D is right. I want to double check. So I'm just going to rub this off and give another value now. Because k is an element of all reals. Let's say k now is equal to -3. Let's draw that. So the asymptote will be over here now. And the graph will go like this. So if I'm thinking, okay, so 1 is over here. So this is 1. So, okay, the x-intercept would be very far, so nope, still wrong. X equals k, but k is an asymptote, so that's wrong also. X equals e, so 2, which is now over further away, which is over here now, which is even more further, so nope. X equals 1 plus k, so 1 plus k, so 1 plus, so 1 minus 3, which is -2, which is over here. We're going to draw a tangent. Okay, we get a much maximum. What about this one? E plus k. So we're saying, let's say 2 minus 3, which is -1. So we're saying -1, which is over, let's say over here. Okay, so the most maximum is D. Yeah, D looks right. Is that right? Yeah, D looks right. It gives the most maximum. A horizontal axis intercept. Okay, next one. The graph of y equals blah, blah, blah is shown below. So there is some transformations we can see that's happened, but wait. The graph of y is shown. So this has already been transformed originally. So this one's already been transformed. And what we want to do is, for all the scales of the scheme, above y equals fx. So we want to get back to the original function. Okay. To do that, I'm just thinking, what can I do? Okay, to do that is, we're going to do what's happened to f of x, but we're going to do the opposite. So, for example, it's been translated left 1 unit. So we're going to translate it at 1 to the right 1 unit. So it'll be f -2x now, because we've translated 1 unit to the right. So if we're translating it 1 unit to the right, it's going to look like, so this is -1 over here. It will be here. So it'll look like this still. And this like this. Something like that. Now, what we want to do is, we want to get rid of that negative over here. So we're going to reflect it, along the y-axis. So to do that, we'll get f2x. So to do that, I'm just going to use a different color now. It will look like this, and this will go down like this and go like that. Yep, looks like that. Now, there's also been a dilation by a factor of half, so parallel to the x-axis. So what we're going to do is, we're going to dilate it by a factor of 2 parallel to x, so we'll get fx. So we'll get our original function, which will mean that if we're going to dilate it by a factor of 2, what we're doing to the x values is, we're going to kind of making them bigger, I think so. So bigger. Yeah, I'm very confused with that one. But I know that the graph, okay, something happens to the x values, but I'm not too sure. But that's not a problem, because we've done so many. So this is our graph. So this is our graph right now. The orange graph. Let's look which ones look similar. Okay, let's look at first A. Okay. Wrong. It's because our one, this value here is supposed to be over here. This one, also wrong. This one, also wrong, because this is supposed to be like that. Like our one. Okay. D, okay, so it has that. As that. Looks right. Let's look at E. Okay, E is also wrong. This is supposed to be under. So D is your answer. I hope that is right. D is your answer. Okay, I hope you guys enjoyed this video. Yeah, I'm at uni right now, so yeah, I had to do this quick. Because I got a class in like another 10 minutes. So yeah, I hope these are all right. Maybe one wrong, who cares? But yeah, I hope they can help you to check your answers, because the solutions haven't been posted by VCA. So yeah, you can use mine as a reference. Have a good day, guys. Bye.